Okay, so in this part one of this lesson on logarithmic functions, we're going to look at four things. We're going to talk about changing from logarithmic form to exponential form, and then we're going to change from exponential form to logarithmic form. Then we're going to talk about how to evaluate, and this should be logarithms, how to evaluate logarithms, and then we're going to use basic logarithmic properties. Okay, so before we go on, though, let's talk about the definition of a log function. So this will be a definition of the logarithmic function. All right, so it starts out with talking about the domain. So it'll say for x greater than 0, and so we'll explain what that is for x greater than 0, and b greater than 0, where b does not equal 1. It says this: y is equal to the log of x base b. So look at this notation. So log of x, see how it's written in that same line? It's level, horizontal. The b is a subscript. Okay, so that's your base. So make sure you write as a subscript. Is equivalent to b to the y equal x. Okay, so notice when we talked about exponential functions. Let me just remind you about this. So we talked about exponential functions where we had f of x equal b to the x. All right, so remember he said that the base must be a positive number, okay? And we also, the base cannot equal 1, okay? The same thing applies here. So the base of a logarithmic function must be bigger than 0, and it cannot equal 1, okay? And okay, and so we're going to talk about why this must be true in a little while. But basically, you're going to go from a log expression, a log equation, to an exponential equation, and then you'd go from exponential equation to a log equation. What you need to remember, you see this y right here, where y is this exponent, and this y is a log. So basically, logarithms are just exponents. So logs are exponents. All right, so logs are exponents. All right, now, make sure you understand that the base of a log equation is a subscript. So this is your base, and this is your base here. This right here, remember, this is your exponent. And so your exponent, see, y is your exponent, so your exponent here, y, is your exponent here. And we're going to call this x right here, this x, which you're taking the log of, we're going to call that the argument. All right, so we call that the argument. Okay? All right, so it's not that difficult to use. You just got to remember this, that when you have y equals the log of x base b, or the log of base b of x. So remember, you can read this. Y equals log of x base b is read as y equals log of x base b, or you can say y equals log base b of x. All right, so either way is fine. Okay, so let's look at this example. Write, number 1, write each equation, in its equivalent exponential form. Alright, so write each equation in its equivalent exponential form. Alright, number 1. Alright, let's write this as A. Alright, A, suppose we had 4 equals the log of 16 base 2. So 4 equals the log of 16 base 2. Alright, so the answer, so you want to remember, by definition, you can write a log equation as an exponential equation, and vice versa. You can write an exponential equation as a log equation. They're equivalent. This exponent here is a logarithm. Okay, that's what that exponent equals. Okay, so it helps if you determine the base. Now remember, when going from log to exponential, you see the base of the logarithm is the base of the exponential, and your exponent is this term that's on the other side. So you'll say, this is how you're going to read it. You're going to say b to the y equals the argument. B to the y equals the argument. The base to the other side equals the argument. So basically you're going to say this. You're going to say the base, always start with the base first. You're going to say 2 to the 4th power equals the argument. And so there's your answer. That's exponential form. Alright, B. Let's suppose you had 2 equals the log base 3 of x. So the answer, you want to change that log equation to exponential form. So you're going to say the base, always start with the base. The base of this log is 3. So the base of exponential will be 3. So you say 3 to the 2nd power equals the argument. 3 to the 2nd power equals the argument. And so there's your answer. That's all they want you to do. C. Suppose you had 5 equals the log base b of 32. So again, think of the base. The base here is b. So you'll say b to the 5th power equals 32. And there's your answer. And then finally D. Suppose you had the log base 6 of 216 equals y. So again, always look at your base first. What's the base of the logarithm? Is 6. So the base of the exponential will be 6. So you'll say 6 to the other side, which is y, equals the argument, which is 216. Okay? Alright, so that's number 1. So that's this part here. So we just talked about how to change a log from going from log form to exponential form. So changing a log equation to an exponential equation. Alright, so that was that. Now we're going to talk about changing from exponential equation to a log equation. So we're going to go backwards. But again, if you know what the base looks like, if you know what the exponent is in terms of the log, and that the other side of this base and exponent, that's the argument, then you're fine. Alright, so number 2. Alright, so let's write each equation. Write each equation in its equivalent log form, logarithmic form. Alright, so write each equation in its equivalent logarithmic form. Okay, A. Suppose we had 2 to the 3rd equal 8. Alright, so this is in exponential form. Let's write it in log form. So the answer. Alright, so you're going to have an equal sign, and you're going to have a log, log. Alright, so first of all, denote the base here. What's the base? Well, the base is 2. So that's going to be the base of this log. So be a subscript. Make sure you write as a subscript. So remember, going back to how we did this, we said 2 to the 4th power. So that 4th power is your exponent. 3 to the 2nd power. That 2nd power is your exponent. B to the 5th power. That 5 is your exponent. and so on. Okay? So you'll say 2 to the, and then you got to figure out what goes over here. Well, your exponent's 3, so your exponent goes here. And then your argument is this 8. So you say 8. Okay? So 2 to the third power, 2 to the third power equals 8. All right, B. 2 to the negative fourth equals 1/16. So the answer. Okay, so you can say equals log. So you got to figure out what this base is first. So the base here is 2. So 2 goes here. And your exponent's negative 4. So let's think about this. 2 to what power? So 2 to the exponent. So my exponent here is negative 4. So negative 4 goes here. And the argument is this right here. So 1/16. Okay? So that's your answer there. C. All right, so you have the cube root of 8 equal 2. All right, now let's kind of review something from another course. Let's talk about the cube root of 8 for right now. So remember, when going from exponential to logarithm to a log form or log equation, you gotta rewrite this as an exponent. You need to know what this exponent is. What's the exponent that goes here? All right, so you got to rewrite the cube root of 8. So you got to remember this. All right, so let's talk about this for a moment. If I have b to the 1 over n, and this is from math, and that was from math 98. So you have b to the 1 over n, 98, 99. You have b to the 1 over n. You can always write this as a radical. You can write this as a radical. So your n is your index, and the numerator, so the denominator is your index, and your numerator is your exponent. So basically you're saying this. You're saying the nth root of b to the first power, which becomes, and b to the first power is just b, so that becomes the nth root of b. Okay? So rewriting this right here, so 3 is your index, so I can rewrite this as 8 to some power. So my numerator, see this right here looks like this. So my numerator is 1 and my denominator is the index, and my index is 3. So the cube root of 8 becomes 8 to the 1/3. Cube root of 8 is 8 to the 1/3. So if you had the fourth root of 5, then that would be 5 to the 1/4. Your index is your denominator. And this right here is 1. So if extending this rule, if you had, let's say, the fifth root of 3 squared, then that would be 3 to the 2/5. All right, so your index is your denominator and your exponent is the numerator. So this exponent here is understood to be 1. This exponent of 8 right here is understood to be a 1. All right, so basically we need to rewrite the cube root of 8 using an exponent. So this is going to be 8 to the 1/3 equals 2. Now that I have an exponent, I can change it to log equation. So I'm going to say equal log. Now your base, determine the base first. The base is 8, so that's going to be your base of this log. So log base. So now you're going to say 8 to what power? So the exponent is going to be this exponent here, 1/3, and it's equal to the argument, which is 2. So 8 to the 1/3 equals 2, and this is what this is. All right, D. Suppose you had 13 to the second power equals x. So the answer, in terms of log form, you'll say log. The base here is 13, so the base here is going to be 13. So 13 to what power? So what's going to be this power here? Well, it's going to be this exponent, so that's 2. And the argument is going to be this term here, which is x. So 13 to second power equals x, and that's what this is. E, suppose we had 7 to the y power equals 200. So the answer, okay, so you have log. So you write a log, so write the log, the word log first. So determine your base. The base is 7, so my base here is going to be 7. So 7 to what power? So what's this power? Well, that's going to be this exponent right here. So that's y. And the argument is going to be 200. And so there's your answer. So 7 to the y power equals 200 is the same thing as saying y equals the log of 200 base 7. Okay? Alright, so that's going to take care of that part. So we talked about going from log form to exponential, and then going from exponential to log. And basically all we needed to know was this right here. So going from log equation to exponential and vice versa. Alright, so those two things are equivalent. Alright. Number 3. Okay, now what we're going to do is we're going to evaluate logarithms. So evaluate logarithms. Alright, so number 3. Alright, so the direction is going to say evaluate without using a calculator. Evaluate each expression. Evaluate each expression without using a calculator. Alright, so number 1. Okay, so let's suppose we had the log of 16 base 4. Okay, log of 16 base 4. And so you want to figure out what this equals to. Alright, so you want to figure out what this equals to. So basically, in your mind, you're going to say this. You're going to say log of 16 base 4 equals, let's say, what goes in this box. You could call it x if you want to. You can call it x. So you'll say, now remember, so you kind of have this log equation now. So you'll change it to exponential form. So you can change it to exponential form. So you say 4 to the box equals 16. And so now the question is, what's this exponent? So 4 to what power 16? The answer is 2. 4 squared 16. So the answer is 2. All right, so in your blank, you're going to put 2. That kind of makes sense because 4 to what power 16? 4 to what power 16? 4 squared is 16. So 2 goes here. Number 2, suppose you had the log of 64 base 2. Log of 64 base 2, same thing. You'll say 2 to what power is 64. So again, 2 to what power is 64. So what goes in this box? Well, 2 to the 6th power is 64. And think about 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So 2 to the 6. So the answer here is going to be 6. So the log of 64 base 2 is 6. Now, soon we're going to look at something called the base change formula. So if we're going to use a calculator with this, we're going to use a base change formula. But these are easy enough to where you can do without a calculator. So the numbers work out. So 4 to what power 16? The answer is 2. 2 to what power 64? The answer is 6. So remember, the logarithms are nothing but exponents. So remember what we said earlier. Logs are exponents. Logs are exponents. So that's what we're doing. We're looking for that exponent. 4 to what power is 16? So what's that exponent? The exponent is 2. So this is equal to an exponent of 2. 2 to what exponent is 64? The answer is 6. So this right here, this log expression is equal to 6. This log expression is equal to 2. All right, 3. Let's call this A, B, C, just to be consistent. So this is A, this is B. All right, C, suppose we had this. All right, suppose we had the log of 1/5 base 5. Log of 1/5 base 5. All right, so again, you're trying to figure out what is this exponent right here. Okay, so you'll say 5 to the box equals 1/5. 5 to the box equals 1/5. Okay, now you got to remember some stuff from a previous course. So remember negative exponents. So when we have b to the let's say negative n power, then that means the same thing as 1 over b to the n. All right, so rewriting your negative exponents with positive exponents, this is the property you used. So this was from a previous course. So if you look at this, so the question is 5 to what power is going to be 1/5? See, this base is 5 and this denominator is 5. So if you said -1, the answer is correct. Because according to this, 5 to -1 becomes 1 over, so I got to rewrite this negative exponent using a positive exponent. So to rewrite using positive exponents, I'm going to say 1 over 5. So the answer here is just -1. So 5 to the -1 equals 1/5. Okay, D. The log of the square root of 7 base 7. So you'll say, so you want to see what that equals to? So you'll say 7 to what power is the square root of 7? All right, so this right here, see the square root, that goes back to something we talked about earlier right here, where we wrote the cube root of 8 as 8 to the 1/3. So you want to do the same thing here. So the square root of 7 right here, the square root of 7 is 7. Remember, if the index is not there, it's understood to be a 2, hence the phrase square root. So this is 7 to 1/2. Okay, so you want to say 7 to what power? 7 to 1/2. Well, if you think about it, since the base is the same here, then these exponents should be the same. So this is 7 to the 1/2 power. 7 to 1/2. So the answer here, log of the square root of 7 base 7, in the blank, you're going to put 1/2 in the blank. All right, so remember we did, we had to rewrite this using an exponent. So 7 to the 1/2 is what this is. So to fill in this box, since these were the same, then the exponents had to be the same. Kind of makes sense, because if we had, let's say, 2 to the x power equal 4, right? 2 to the x power equal 4. So you let's make it 8, so I don't have to have that many 2's. So 2 to the x power equal 8, you can look at this and tell me what x is. 2 to the 3rd power is 8. But remember, 8 is the same thing as 2 cubed. So since the bases are the same, these exponents should be equal. So x should be equal 3. So since the bases are the same, this box should equal 1/2. So the log of the square root of 7 base 7 is just 1/2. E. All right, suppose we had the log of 1 over the square root of 2 base 2. 1 over square root of 2 base 2. All right, that's going to be a little challenging, but think about all the stuff that we've done so far. Now, you're going to have to use the idea of negative exponents. So you have to use this idea. You're going to have to use the fact, well, how do I write a radical as a base raised to a power? Okay, so you have to use this idea as well. So here, all right, so here what I'm going to do is I'm just going to go ahead and first of all rewrite this over. And so this is box. I'm going to say 2, so you can write this as exponential. So 2 to what power is 1 over the square root of 2? Okay? Now, what I would do next is probably rewrite this right here as an exponent. So the square root of 2, remember, is 2 to the 1/2. And so that becomes 2 to the box equals 1 divided by 2 to the 1/2. And so in one of your previous courses, you learned this. So this right here, where we had b to the negative n is 1 over b to the n. Well, you also learned this. You also learned that 1 over b to the negative n. So you see how my exponent is negative in the denominator? So I just rewrite this term in the numerator. So this is just b to the positive n. So 1 over b to the negative n, to make that exponent positive, I just rewrite it in the numerator, and the exponent, the sign of the exponent changes. So a negative n becomes a positive n. So right here, when I rewrite this and put it in the numerator, the sign changes. So I get 2 to the box equals 2 to the negative 1/2. Okay, so 2 to the 1/2, when I bring this term in the numerator, I get 2 to the negative 1/2. And the reason I'm doing that is because I'm trying to get right here in order to kind of discuss what this equals. Because if you don't look at it this way, you may not even figure this thing out. But the bases are the same, so just like we did here, remember the bases are the same? So the exponents have to be equal. So the bases are the same, then these exponents have to be equal. So this box right here has to equal a negative 1/2. So this should equal a negative 1/2. So negative 1/2 goes here. So 2 to the negative 1/2 is 1 over square root of 2. So let's think about this. Is that true? So let's check. Is 2 to the negative 1/2 equal to 1 over the square root of 2? All right, well, remember, let's rewrite this without a negative exponent, so that part is 1 over 2 to the 1/2. And we also know that 2 to 1/2 as a radical is the square root of 2, which is what this is. Okay? All right, so some of these are challenging, especially when you have these radicals. So C, D, and E were a little bit challenging because of all those negative exponents and radicals. All right, F. Okay, so F is the log of 8 base 64. Log of 8 base 64. All right, so we got to figure out what this is equal to. So equal to blank. So let me go ahead and rewrite this over, and we're going to change this to an exponential. So that's what we're doing. We're changing exponential. So 64 to what exponent? 64 to what exponent is 8? All right. So if you look at this, 64 to what power is going to be 8? Now, if you keep thinking integers like positive whole numbers, it's not going to help you. Because 64 squared, 64 cubed, 64 to the 4th power, there's no way that's going to be 8. So you got to think fractions. So if you remember, isn't the square root of 64 equal to 8? So you see, that has to be a square root of 64. But remember, how do you write the square root of 64 as an exponent? Well, that's 64 to the 1/2. Remember, this index right here is supposed to be a 2. And so that's what this is. This box right here, this exponent, is 1/2. So 64 to the 1/2 is 8. So 1/2 goes here. All right, G. We have log of 5 base 5. All right, now that one's a little bit easier than the others. So you'll say, so you want to figure out what this equals. So you're going to rewrite this as an exponential. So you'll say 5 to the box equal the argument, which is 5. So 5 to what power is 5? Well, 5 to the first power is 5, so that equals 1. 5 to the first power equals 5. That makes sense. 5 to what exponent is 5? Well, the exponent has to be a 1. So it's a little bit harder to see here without doing some work, but 64 to the 1/2 is 8. The square root of 64 is 8, so 64 to the 1/2 is 8. All right, H, suppose we had log of 1 base 4. Log of 1 base 4. Okay, well, so I want to figure out what this equals. So we're going to rewrite this as an exponential. So log of 1 base 4 equals box. So let's figure out what this exponent is. I'm trying to understand what this exponent is. 4 to what exponent? 4 to what exponent is 1? Well, think about this. 4 to what power is 1? So remember, there was something we learned in previous courses, and even we talked about this in here. So when you have a non-zero base raised to the 0 power, that's 1. So any non-zero base raised to the 0 power is 1. So 4 to the 0 power is 1. So 4 to what exponent is 1? Well, the answer is 0. 4 to the 0 is 1. I, suppose we had this. Suppose we had log of 5 to the 7th base 5. log of 5 to the 7 base 5. So I'm going to figure out what that equals to. So let's go ahead and change this to an exponent in the exponential form. So log of 5 to the 7 base 5 equals some exponent. So 5 to what exponent? 5 to what exponent is the argument, 5 to the 7. So now that goes back to what we talked about earlier. If the base is the same, then these arguments, if the base is the same, then the exponents have to be the same. So 5 to what power is 5 to the 7th? Well, that power has to be 7. So this has to be 7, so this has to be 7. 5 to the 7 is 5 to the 7th. All right, J, 8 to, and then you'll have this, log base 8 of 19. So 8 raised to the log base 8 of 19. So the log of 19 base 8. Okay, so to do that, let's think about something we talked about earlier, right here. So let's look at this for a moment. Let's look at this. So I'm going to go ahead and rewrite this over. You remember earlier we had 7 to the y power, that's a y, equals 200. And you want to change this to, that's a y, say not a 4. And you want to change this to an to a log expression. So we'd say log, the base is 7, so you'd say 7 to the y, and the argument would be 200. Okay? And so remember we said that an exponent is a logarithm. So I'm going to replace this y with this side here, because that's what y equals. So I'm going to say 7 to the log base 7 of 200, and notice this right here is going to equal 200. So basically what we found is this: when the exponent is a logarithm, okay, the exponent is a logarithm, and this base is the same as this base, then the answer is the argument, is just 200. So again, what we did was this. So we saw earlier that 7 to the y is 200 is equivalent to this log expression. And then I'm just going to replace this exponent with what, so this is y, so y equals this. So I'm going to replace this equation, I'm going to put in the exponent the log expression. So the log of 200 base 7. All right, and so notice that when your equation, the exponent is a log, and the base here is the same as this base here, then the answer is just the argument. Okay, so this means this. So you see that kind of looks, this right here looks like this. So see how this base, the exponent is a log expression. But what do you notice about the bases? You notice the bases are the same. So what is this going to equal? It's going to equal the argument, which is 19. So it's kind of like if you had this again. Let's suppose we had 6 log base 6 of 400. What do you think the answer is? Well, whenever you have the exponent being a log, and the base of this log expression is the same as the base here, then the answer is just the argument, 400. Okay? All right. Now, I think that takes care of what we want to talk about. So we talked about here, see this basic log properties? So the basic log properties that they were referred to, we've already done. So let me show you what that was. So the basic log properties were these. Basic log properties were these. So the first one was this. So the log of b, base b equals 1. That was the first one. So it kind of makes sense because b to the first power is b. So b to the first power is b. And we use that here. So that's for that first property. 5 to the first power is 5. All right. Then the other property was this. The log of 1 base b equal 0. So when the argument is 1, whenever the argument is 1, this has to be a 0. So b to what power is always going to be a 1? Well, that's going to be 0. right? So we use that property. We use this with this one. So regardless of what the base is, the base could be anything. This could have been a 400. 400 raised to what power is 1. As long as the argument's always 1, this answer is going to be the exponent. 4 to what exponent is 1? That's always going to be a 0. Okay? So those are the two properties that we were referring to when we said use basic log properties. So those were the two. Now there's some other properties, but for this lesson, those were the only two we're going to look at this point. Okay, so that's going to take care of part 1. So part 1 was just changing from a log equation to exponential, then changing from, if I can find it, then changing from exponential to log, and then the last part was evaluating log expressions. And remember, to evaluate log expressions, we changed this to we changed this log expression to an exponential. So we said 4 to what exponent is 16. So 4 squared is 16. We said 2 to what power is 64. So 2 to what power is 64? 6. Then it got a little bit more challenging, I guess, when we were talking about when we had fractions, we had negative exponents, then we had radicals. We had to rewrite the radical using exponents, rational exponents, and so on. So this section can be a little bit challenging if you don't remember some things from a previous course. Okay, but that's going to take care of this lesson on logarithmic functions.